This is the Space Museum at Cape Kennedy, a museum of missiles and rockets, launch vehicles that in days past laid the groundwork for the future, for centuries to come. But here, unlike most museums, the past is not too far back. The oldest missile in this museum is 22 years old, the newest barely 2 years old. In the space age, no matter how great the accomplishment, it is inevitably surpassed and winds up at a museum. Because of what happened here at Cape Kennedy during 1966, the list of candidates for inclusion in this museum grew considerably.
1, 0.
Missile launches from what was then called Cape Canaveral started in the summer of 1950, just 17 years ago. The first bird to fly from the Cape was a captured German V-2 with an Army-developed second stage called Whack Corporal. Back in those days, the Cape was barren. 25 square miles of scrubland. Alligators, rattlesnakes, sand, and swamp. Today, it's different. From out of the scrubland, huge metal towers have risen. Concrete launch pads and blockhouses have taken form, and a myriad of bizarre-looking antennas have appeared. This is Cape Kennedy today, the first station on the Air Force Eastern Test Range and the focal point of American progress in space exploration and missile development. Here, thousands of Americans from all over the United States work with a sense of urgency on some very important projects. Projects like Minuteman, a vital link in the nation's defense forces. Minuteman II, currently being tested at the Cape, is our country's newest intercontinental ballistic missile. 3 stages, solid-fueled, with a striking range of nearly 7,000 miles. At the same time that these test missiles are being launched at the Cape by Air Force missile men, operational versions are being deployed with the Strategic Air Command in silos in the western United States. At present, more than 900 Minuteman ICBMs have been turned over to SAC. They stand alert as a deterrent to any would-be aggressor, because in their bomb-proof operational silos, they can be launched in less than 60 seconds.
7, 6, 5, 4, 3, 2, 1, 0.
During 1966, all Minutemen launched on the Eastern Test Range were successful. A different concept in a long-range weapon is the U.S. Navy's Polaris Fleet Ballistic Missile. The difference is that the launch pad for the Polaris moves, because a nuclear submarine carrying 16 Polaris missiles can patrol underwater for months at a time, on alert, hidden, ready to strike on short notice in defense of an attack on the United States. In test shots at the Eastern Test Range, the Polaris nuclear submarines cruise 30 miles off the Cape's coast, submerge, and then the crew makes ready for launch.
The range is clear. Counting.
Supervisor weapons, initiate fire, missile.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
Set the fire green.
2,800-mile range Polaris scored 25 successes in 26 attempts during the year. Weapons testing continues, but the emphasis over the years has changed from development of defense systems to the programs involving the peaceful exploration of space. This is the Thor Delta rocket. The days when the Thor was developed by the Air Force as a weapons system have long since passed. Today it is America's prime satellite booster, used by NASA and the Air Force. Each satellite serves as an extension of man's own senses in space. These extensions see, hear, record, and send back information about radiation, heat, solar winds, meteorites, and other phenomena. A satellite shot would have made headlines less than a decade ago, but in 1966, the event has become familiar, commonplace, almost routine. Space feats are now an everyday fact of life. Numerous satellites were launched from Cape Kennedy during the year, benefiting Americans with improved global communications, better weather information for forecasters, and more knowledge about space. Each launch is a unique event, and the preparations necessary to gather information from a missile or space launch is a complex affair. The range, or shooting gallery, established almost 20 years ago to support missile development, has grown from a few hundred miles in length to a 10,000-mile-long laboratory starting at Cape Kennedy and ending in the Indian Ocean off the east coast of Africa. The range is now tailored to meet the requirements of the Department of Defense and the National Aeronautics and Space Administration. Down this 10,000-mile length of tracking stations, ships, and aircraft, dedicated people are at work behind the scenes, operating radars, telemetry equipment, gathering information, knowledge. The events that occur on the Cape and the range attract international attention and some very prominent visitors. On February 25th, Her Royal Majesty, Queen Elizabeth of England, and Prince Philip, the Duke of Edinburgh, visited the Air Force tracking station at Grand Turk Island, some 750 miles southeast of Cape Kennedy. Grand Turk, like many of the other United States missile tracking stations, is on foreign soil. But through cooperative agreements with other governments like Great Britain, the work of the space age can continue, benefiting all men everywhere. Later in the year, the Space Center received a brief visit from our own head of state, President Lyndon B. Johnson. Special guest for a tour of Cape Kennedy and the NASA moonport was West German Chancellor Ludwig Erhard. After a briefing on Project Gemini and American plans to land men on the moon by 1970, the President spoke to the spaceport workers, praising their accomplishments. 4 hours after their arrival, the President and his party returned to the Capitol. At the Cape, words become action. Research and development tests of America's newest space rocket, the Air Force Titan 3C, continued on schedule. During the year, the new Titan flew 3 separate flight tests to further prove some basic Air Force concepts and the general feasibility of an inexpensive, quick-reacting, versatile space rocket designed to perform any number of military space missions. A mission like placing 8 satellites into Earth orbit in one launch, because on June 16th, the Titan III would be called upon to do exactly that. The 8 satellites consisted of 7 military communication satellites and 1 gravity gradient. To achieve proper orbit, the Titan III's 3rd stage would be required to start and stop its rocket engine 3 times, an ambitious and unprecedented effort. 8 satellites in one shot. It had never even been attempted before. The Titan III performed perfectly, placing all 8 satellites into proper orbit. The mission was a complete success. Three months later, another Titan III attempted to give a repeat performance. Again, 8 satellites were aboard, and the flight plan duplicated the previous success. All systems ran smoothly until some 80 seconds after liftoff, when the nose fairing appeared to break up, causing the Titan III to pitch over and explode. Telemetry information revealed that the Titan rocket systems did not malfunction. Only the aerodynamic forces from the premature fairing separation and the tumbled attitude caused the explosion. Scenes such as this one are a rarity these days, but still are, above all, a disappointment. Setbacks are frustrating, but they are also lessons for future flights. And the future holds great promise for the Titan III. In the continuing research and development program, different kinds of payloads will be launched to test the new rocket's versatility. These launches will pave the way for eventual manned launches of the Titan III in the Department of Defense Manned Orbiting Laboratory program. In November, Air Force engineers would attempt a most complex space mission for the Titan IIIC. First, launch an unmanned modified Gemini spacecraft 5,000 miles downrange to test a new type heat shield. Then, fire up the rocket 2 more times and place 5 satellites into orbit. Newsmen called it an aerial circuit.
This is Titan III Launch Control. We have the range clearance to launch from the Superintendent of Range Operations. And in a moment, the pad safety officer will close the firing line switch, one of the last items in the countdown. All eyes now on the TV monitors here in the console room. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
Special slow-motion cameras record the dramatic liftoff.
Climbing very nicely. She's on time on the line. The telemetry indicates that she is good. She is sending back excellent data. Should have confirmation of Mark II. Mark II. The solid rocket motors have separated. The vehicle is now at an altitude of 24 miles and is 28 miles downrange. She's on time on the line. Velocity approximately 5,879 feet per second. We have just had a preliminary report of a visual contact with the Gemini spacecraft. It appears to have landed pretty close to the nominal.
The modified Gemini spacecraft withstood the re-entry as anticipated, and all 5 satellites were placed into orbit. The mission was an unqualified success. The programs at Cape Kennedy during 1966 varied, but the largest singular effort was aimed at getting man on the moon by the end of this decade. In 1966, man stood on the threshold of that great adventure and moved forward, exploring the unknown, reaping untold quantities of new information. To aid in this preparation, NASA's Lunar Orbiter, a camera-carrying spacecraft, was readied for launch and installed atop an Atlas Agena rocket. The spacecraft was scheduled to go into orbit around the moon and photograph possible lunar landing sites for future astronauts. The launch phase was perfect. The spacecraft moved through space and went into the pre-planned orbit around the moon. The pictures sent back were remarkable. a view of the Earth with the moon in the foreground. Photographs from only a 28-mile altitude. During 1966, 2 separate lunar orbiters sent back pictures such as these. Taking pictures of the moon is one thing. Landing on the lunar surface is quite another. And that would be the task of NASA's Surveyor spacecraft. The mission: launch this spacecraft on an Atlas Centaur rocket, travel more than 240,000 miles through space, make a soft landing on the lunar surface, and then begin sending pictures back to Earth. Launch was scheduled for Memorial Day, 1966. The world listened for news as Surveyor approached the moon.
Surveyor is reported in excellent condition. All signals look good. 4,000 feet, stable. 400 feet. 200 feet.
100 feet per second.
100 feet.
100 feet. 100 feet. 13 foot per second.
13 feet per second speed.
Touchdown.
Touch. The button keys report touchdown.
The pictures revealed for the first time that areas of the moon are solid enough to support a landing vehicle. Details of the lunar surface, never revealed before, passed into the realm of established fact. All this knowledge leading to Project Apollo. Apollo, the target. Honoring the mandate of President John F. Kennedy.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
One of the most difficult steps in the lunar mission is the development of the launch vehicle and spacecraft. To answer this need, NASA continued development of the uprated Saturn I rocket and the 3-man Apollo spacecraft during 1966. The Saturn's unbroken string of successes continued with 3 flights during the year. On 2 missions, the Apollo spacecraft was rocketed back through the atmosphere, primarily to check out the heat shield. In these missions, the worldwide support network of the Department of Defense and the military recovery forces played their key roles. These successes were milestones in helping qualify this Apollo hardware for the grueling missions ahead. Many Americans got a preview of what the real Saturn V moon rocket will look like when a mock-up model, fully assembled, was revealed for the first time in May. Moved by a giant crawler transporter, the Saturn V, high as a 37-story building, is a man-made machine that represents the near future at the Kennedy Space Center and the determination to place man himself on Earth's nearest celestial neighbor. But in space, machines can only do a limited job of exploring. No machine has ever been built that has the dexterity of a hand, the perception of an eye, the judgment of a human brain, or the courage of conviction. Therefore, man must be sent to explore, to learn, and to bring back the human story of this adventure. Man first met this space-age challenge in Project Mercury. The objective, send 1 man into space in a tiny capsule as a passenger to see if he can live. He could. After Mercury came Gemini, the difference being that now 2 men went into space, not as passengers, but as pilots. They would do useful work in space to see how well man could perform. For every man that NASA sends into orbit, thousands are operating behind the scenes, supporting the mission. They are all vital. This fact was made abundantly clear on March 16th. The mission was Gemini 8, and the astronauts, civilian Neil Armstrong and Air Force Major David Scott, would attempt to rendezvous and dock with an Agena target vehicle. At Pad 14, the Air Force Industry Launch Crew, headed by Air Force Lieutenant Colonel Jack Allen, prepared the Atlas Agena for launch. The target was programmed for a 161-mile circular Earth orbit. Colonel Allen heads the team that prepared and launched all the Atlas Agena target vehicles for NASA. With the Atlas Agena injected into orbit, the attention turns to Pad 19, where another launch team, led by Air Force Colonel John G. Albert, is monitoring all systems, making sure that the modified Titan II rocket and Gemini spacecraft are ready to go. There is more at stake in this launch. There are 2 men aboard. Colonel Albert, who has supervised the launch of every Gemini astronaut into space, remembers what it was like.
There was always a big buildup, psychologically and emotionally, and at the launch. Just like an athletic team, you build them up for a major undertaking. You can't keep them up there all the time. So then you'd be faced with the thing of getting these people back to their razor sharpness for the launch. And you could actually see it build up. The 3-second hold down after engine ignition seems like an eternity.
Once in orbit, astronauts Armstrong and Scott closed in on their target, and the first space docking in history took place.
And he's really a smoothie.
We flight, we are down.
Oh, Roger. Hey, congratulations.
But shortly after docking, trouble. A thruster on the spacecraft jammed open, causing the craft to roll violently. Training paid off. Using the re-entry control system, Armstrong managed to stabilize the spacecraft. NASA officials decided to end the mission after only 6 revolutions, and a secondary landing area 500 miles east of Okinawa was chosen. Air Force rescue aircraft from bases in Japan and Okinawa raced to the scene. One of the planes spotted the spacecraft before it hit the water. 3 hours after splash, the U.S. Navy destroyer Leonard Mason pulled alongside and made the pickup. The mission was over. The astronauts safe. The Department of Defense forces, which are a vital part of every manned mission, did the job. As the year progressed, Project Gemini forged new frontiers in space. In May, GT-9 astronauts Tom Stafford and Eugene Cernan rendezvoused with their target in space successfully. However, a faulty protective covering had failed to separate, causing Stafford to report a meeting in space with an angry alligator. GT-10, a 3-day mission flown in late July, featured John Young and Michael Collins as the crew. They conducted successful rendezvous, docking, and more extravehicular activity. GT-11, flown in September, had Pete Conrad and Dick Gordon aboard. Among the achievements of this mission was a rendezvous with the target vehicle on the first orbit. Astronaut Gordon also walked in space, but the heavy workload made him extremely tired, and Command Pilot Conrad ordered him back in early. Finally, the astronauts fired up the Agena and set a new altitude record of 850 miles, higher than man had ever gone before. November 11th, 1966. launch day for the last Gemini mission in history. The GT-12 astronauts, Navy Captain James Lovell and Air Force Major Buzz Aldrin, prepared to make the last Gemini two-man assault on the frontier of space. Once again, the Atlas Agena target vehicle performed perfectly. But at Pad 19, there was work to be done. The Titan II, with the two men aboard, would have to be launched right on time to effect a close-in rendezvous with the target. The countdown clock ticked off the seconds, and the last chase in space for Project Gemini was about to begin.
9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Roll program.
Roger, roll. Roger the pitch.
Go for station.
Roger, your go for staging on the ground.
Houston, and tell the sea lights out now.
Roger, copy. You're steering right down the pipe.
Everything was go, and a few hours after liftoff, another rendezvous and docking was successfully performed. Later in the mission, Buzz Aldrin walked and worked in space. Still later, a station-keeping experiment using a tether to tie the spacecraft to the Agena was accomplished as planned. After 4 days in space, the astronauts re-entered the Earth's atmosphere for a splashdown in the western Atlantic Ocean. These unusual films were shot from the spacecraft during re-entry. Down below, the prime recovery ship, the aircraft carrier Wasp, was ready. Splashdown, only 3 miles from the Wasp's deck, an outstanding success. The Gemini 12 mission was the last in the two-man Gemini series. The accomplishments of the project were many. Walks in space, rendezvous, docking, all sorts of new space records for America. But Gemini leads the way for far greater accomplishments in Project Apollo and placing 3 Americans on a journey to the moon. The accomplishments to come at Cape Kennedy will be many, and numerous programs in space exploration and defense will be active, challenging, and exciting. But for Launch Pad 19, there is no future. The job is finished and the pad is abandoned. No longer will skilled hands check out fuel lines and electrical circuits here. No longer will space travelers walk to this place in search of accomplishing the fantastic. No longer will the eyes of the world focus here. Because in the year 1966, this service tower, this blockhouse, this launch complex became a museum piece. This stepping stone toward tomorrow is now obsolete. Tomorrow has arrived, and the rush of time has passed this place by.
Go. Landline instrumentation. Go. Telemetry in liftoff mode. Go.
7, 6, 5, 4, 3, 2, 1, 0.
There she goes.
Roger, how's your thrust?
There goes the pitch.
Roger pitch. You're on your way, Molly Brown.